I want the systematic names of these compounds, so spelling counts, okay? And as you can see, the solution here is, like, I think there's a formatting error. I'm not sure what's happening on the, like this is, I don't know, I can't decipher this at all. So there's something wrong with this. But I'm gonna say solution is incorrect, I guess, because it's not complete. But we will look at filling this out. So this is number 6. So I want the names. So name each compound. So I have CuI in a solid state. I have Fe2O3 in a solid state. I have COF2 in a solid state, and I have FeO in a solid state here. So what I want to do with these compounds is I'm going to, if I want to name these guys here, the trick to this question is these metals here. So I have copper here, I have iron, I have cobalt, and I have Fe here, or iron here. And the trick here is that I have all these metals here are multivalent metals. So they exist in 2 different charges, or 2 or more different charges. So multivalent metals. So therefore they have more than one charge. So why do we care about multivalent metals? Well, it's going to affect the naming of these metals, right? Again, for example, copper has a 1+ charge or a 2+ charge as well, depending on which state it's in. So in this case here, what I want to do is I want to look at how this guy dissociates. I'm going to break up this solid into its ions. So I'm going to simply say this would be copper and iodine, right? Plus iodine here. And as you can see, iodine here is one of our, you could think, I'm not going to balance this chemical equation, but you could think of this as, iodine, again, we know it's a diatomic, so this here it's definitely I2, so therefore there has to be a 2 here. But we don't really want to think of this as our, as a balancing kind of chemical equation. We want to think about the naming here. So in this case, I care about mostly the charge, right? So this here is an I- charge, because I know iodine exists in the fluorine in group 17, where fluorine, chlorine, bromine, and iodine exist in. So I know the valence electrons are going to be 7 valence electrons, so I have a charge of 1- here. And I have to figure out, how do I balance out this 1- charge on copper? Well, I need a 1+ charge, right? Because 1 plus -1 is going to give me 0, right? So therefore, copper, in this case, I will have a 1+ charge. So therefore, the naming, I can easily figure out the naming, right? Because once I figure out the charge of copper, this is an easy name, right? This is simply just copper. So I can name this and say it's copper. Let me use brackets here. So this is copper, and then I put the charge here, which is 1. So copper 1, and the iodide for the naming of iodine. We just drop the INE and we change it to IDE. So this is copper 1 iodide is our solution for the first problem here. Our second is going to be our iron here, right? And iron here is also a multivalent compound, right? So let's again break this up into, and all of these are multivalent, by the way, so we have to break this up into, again, 2 compounds here. So if Fe, and I don't know the charge of Fe first, plus I know the charge of oxygen though, right, which is O, I know it's 2-, and then I think, again, I'm not gonna balance these chemical equations, so I have 2- here. So in this case, I have a 2- charge here, and I want and again, I want something that's that would give me kind of 2 irons here, and also 3 oxygens here, right? So you could think of this as, there's 2 ways to think about it. Again, you can think of this as a crisscross method, where basically the charge of the number here of iron here, which is Fe2, belongs to this charge here. So therefore, the oxygen with 3 would have to be belonging to this charge here. You can think of it as that kind of problem, or you could think of it as, oh, there's two irons here, and there's 3 oxygens here. So therefore, I have in total 3 times 2- here is a 6- charge, and this guy also has to be a 6. I need to balance out the charge of 6-, so I'm going to need a 6+, obviously. And 6 plus divided by 2 here is going to be equal to 3. So in this case here, this would be a 3 plus charge. So again, there's a lot of ways to think about this problem here, but it's again up to you of how to think about this problem. But the crisscross method I find is kind of the quick and dirty way to kind of finish this problem, where you can kind of just figure, oh, I know that this oxygen has 3 here, so therefore this has to be a 3 plus. So you can think of it that way, but it's up to you in terms of how to think of that, how to think about this problem or how to approach this. So again, I have simply Fe is simply just iron. And then I put the charge here, specify the charge, which is 3 in Roman numerals, and oxide is going to be the name of this compound here. Iron 3 oxide. Number 2, I'm going to go a bit faster now. I have cobalt and fluorine here, so I'm going to write CO, and I don't know the charge of CO here, plus fluoride. Now the fluoride has a charge of 1 minus, right? Because again, it belongs to my halogens. If it has a charge of 1 minus here, and I have 2 fluorines here, what am I going to do? Well, I have a charge of now 2 minus, right? I have 2 fluorines here, which means I have a charge of 2 minus. 2 times negative 1 here is negative 2, or 2 minus. So which means cobalt, in order to balance out the charge, is going to have a charge of 2 plus, right? Because 2 plus 2 minus negative 2 will give me 0. So therefore, you can say that this compound is going to be cobalt, so COBALT, cobalt 2, and then fluoride. And that's going to be the charge, that's going to be the name of that compound as well. And finally, let me make some room here. I have this compound here is going to dissociate to Fe something plus O and then 2 minus. And as you can see, we only have one of each, guys. We have 1 iron and 1 fluorine, or sorry, one iron and 1 oxygen. So this is a charge of 2 minus, which means I need a charge of, what charge do I need to make this 0? Well, I would need a 2 plus charge, right? So therefore, this is a 2 plus. And I can say that this compound will be iron, and the charge of iron, which is 2, and the oxide. So these are very, very tricky, right? When we talk about iron 3 oxide and iron 2 oxide, they're very different compounds. As you can see, Fe2O3 and FeO are different compounds here. So again, the solution is incomplete. So solution is incomplete. And then I'm going to say that CuI S I'm going to say the naming or the name, or yeah, CuI. So for CuI, copper iodide, copper 1 iodide, the charge on copper is 1 plus. Therefore, the name of the compound is copper 1 iodide. And then I'm going to copy and paste these guys because I'm going to have to write this up 4 times here. And then I'm going to just simply modify these guys here. So let me space this out. Formatting. This is Fe2O3. The charge on iron here is going to be 3 plus. Therefore, the name of the compound is going to be iron. This is iron 3 oxide. And then this is for copper, or sorry, for cobalt fluoride here, or cobalt 2 fluoride. The charge on cobalt is 2 plus. Therefore, the name of the compound is cobalt 2 fluoride. And then finally, for this compound here, it's FeO. For FeO here, the charge on iron here is going to be 2 plus. Therefore, the name of the compound is going to be iron 2 oxide. And this is the full solution for this problem here. So the solution is incorrect because I can't decipher this problem here.